All right, so last section for this week is 8.1. We'll split it into two days. We'll do part today, and then we'll pick up the next part next academic week. So we're going to be looking at triangles. Okay, we've already looked at triangles before, where we solve for all the sides and all the angles. But when we did it before, all the triangles we worked with had a 90, which means they were a right triangle. Okay? When you work with right triangles, there's certain theorems you can use. What's the name of that theorem that has to do with the sides in a right triangle? It's like if you know two sides, you can find the third. The Pythagorean theorem. Okay, so you can use that theorem as long as you have a 90-degree angle. If you don't, you can't use Pythagorean theorem. The other thing you can use with right triangles is SOHCAHTOA. Because if you have a 90, what's across from it is the hypotenuse. So we can do the opposite of a hypotenuse and adjacent over hypotenuse stuff. Well, if you have a triangle where none of the angles are 90, we can't use the stuff we already know. We're going to do something different. And the name of a triangle that's not a right triangle, it's called an oblique triangle. And there's really two types. Anybody know the two types of triangles that are oblique? What's that? Yeah, you can have an acute triangle. Okay. One example, think of an equilateral. Okay. 60, 60, 60. That's acute. And obtuse. One angle bigger than 90. Why can't you have two angles bigger than 90? It's not a triangle. Okay. All the angles still have to add up to 180. That's a fact we can still use. So there's our diagram for solving oblique triangles. The sides are the same as what we've done before, A, B, C. A always has to be across from alpha. B, you always want to set up across from beta. And then before, C was always across from the right angle. Well, it's not a right angle anymore. So I had to give it another name. Does anybody know what the Greek letter is across from C? Yep, it's gamma. These are all lowercase Greek letters. That's lowercase gamma. Now, you don't have to draw your triangle exactly like that. If you want to flip it around and draw it a different way, that's fine. Just make sure, however you draw it, A is across from alpha, B is across from beta, C is across from gamma. Also, my triangle is never going to be to scale. So gamma might, in a problem, I might draw it like this, but gamma might be 20 degrees. Okay, the picture is just so I can see what is across from what. It's not to scale. All right, so there's three types of problems we're going to look at today. Okay. When you're solving a triangle, they always have to give you three pieces of information. There's 6 total. 3 sides, 3 angles. One way I could give you information to solve is I could give you 2 angles and a side. And even that, there's 2 ways I could do that. This is angle, side angle. And side angle, angle. So you've seen those before when you do proofs in geometry. You use them as abbreviations for theorems and postulates. We're just using them for abbreviations to show what information you have. So this is angle, side angle. Okay, here's a triangle. Let's say this angle is 30. This side is 12. This angle is 100. The information they've given me is 2 angles, and they gave me the side that is between the angles. It's the side that connects them. If they gave me side angle, they're giving me the same information, but this time the side is not between the angles that I know. So this could be 40, 110. And I just have to pick a side that's not the one between the angles. 8. Side, angle, angle. Any questions on that? It's important when they give you information that you know what kind of triangle it is, because there's some problems that are going to use the law of sines. There's 2. And there are some other problems that are going to use the law of cosines. So you have to know which law you're going to use. For this week, that's not going to be an issue. Every problem is going to be law of sines, because I'm not teaching law of cosines till next week. On the next test, there'll be kind of a mixture of these kinds of problems and the other kind that we learned. So you're going to have to know when to use which one. Okay. And also, you might see these abbreviations forward or backwards. Side, angle, angle. You could also call it angle, angle, side. It's the same thing. Angle, side, angle. If you want to reverse the letters there, you can. Go for it. The next type, when you have 2 sides and an angle, I'd prefer you write it in that order. Reversing it's just kind of rude. So if you have 2 sides and an angle, 10, 15, and what's important is the angle that they give you is not between the 2 sides. That's SAS. That's different. We're not going to do that this week. So something like that. Okay. Side, side, angle. So those are the 3 and the only 3 types of problems that you can use law of sines with. The other types we're going to learn that aren't up here yet are SAS. We wouldn't be able to solve it with what I'm teaching you. And SSS, side, side, side. Can't solve that kind of problem with what I'm teaching you. In the past, some people have asked about angle, angle, angle. Any thoughts about angle, angle, angle? I didn't list that as part of what we're doing now or part of what we're going to do, because it's not one we can do. Yeah. Yeah, angle, angle, angle would only allow you to find similar triangles. It's like if I said to you, I have a triangle with angles 60, 60, and 60. It's an equilateral. How long is each side? Could be 2, 2, and 2, or 6, 6, 6. You don't know. You don't know. It could be anything. So angle, angle, angle is not a type we study. Every other type, though, is either listed here or will be listed next class. All right, so to solve angle, side, angle, or side, side angle, we're going to use the law of sines. Okay, so we are going to go through where part of the law of sines comes from. There's 3 parts to it. I'm not going to do the whole thing. Because if you do the first 2 parts, it really shows you where the 3rd part comes from, just extending the pattern. All right, so let's take a look. All right, so all you have to do is start by drawing a triangle. It doesn't have to be a 90-degree angle in it, just any triangle. And next thing I'm going to do is I'm just going to draw a line like that. Okay. What did I just do to my big triangle? Split it into 2 triangles. Can you be more specific? Bless you. 2 right triangles. Okay. I'm going to label some of the sides here. I'm going to need this side. And I'm going to label the angle across from A as alpha. And I'm going to label B and beta. Okay, so if you look at it as the big triangle, A is across from alpha, B is across from beta. So any questions on that? Okay, and then I put that line segment in. to split it into two right triangles. What is that line segment? It's the what of the triangle? It's the height. So h should be a good letter. The only thing is I don't want you to confuse h with hypotenuse. I am going to use h for height. It's also called an altitude. But altitude begins with A, and here we have a side A, so. Right, so h is my height. Okay, so what I'm going to do now is use what I know about right triangles, and I want to come up with a formula for the height. Okay, so I'm going to do it two separate ways. First, you can block off the triangle on the right and focus on the one on the left. I want to use this angle, this side, and that side. What's the relationship of h to alpha? What position is it? It's opposite. And what about side B? Hypotenuse. So what trig function would involve the two sides you just said? Sine. So we're going to write down sine of our angle equals what would go on the other side? H over B. Now my goal was to solve this for h. So how would I put the b on the other side? Yeah, multiply both sides by b. So there's a formula for the height. Okay, b sine alpha. That's all I'm going to do with that for now. Any questions on that? Okay, now I'm going to block off everything I just did on the left, and I'm going to do the same thing on the right. Right? So this time I want to use this angle, H and A. What's the name of side H relative to beta? Opposite. And then A is the hypotenuse. So what trig function are we using again? Sine. So my equation would be sine of beta equals H over A. And now I want to do the same thing. I'd like to get H by itself. Yep, multiply both sides by A. And now you have a different formula, but it calculates the same thing. Okay, so we could call this it's box 1 and box 2. How do box 1 and 2 compare to each other? Yeah. Now, box 1 and box 2 are equivalent because they both equal h. So because they're equivalent, I can write b sine alpha equals a sine beta. Any questions on that? That's box 1 on the left, box 2 on the right. Now, I would like to put the B over with beta, and I'd like to put the A over with alpha. So how would I move B to the right side? Yeah, we'll divide by B. And how would I move A to the left? By, yep, divide both sides by A. So that's going to cancel the B. That's going to cancel the A. Okay, and now we have the first two parts of the law of sines. The sine of alpha over A equals the sine of beta over B. And there's a third part I didn't prove. I could prove it by drawing a height to a different side instead of the one I drew. But does anybody have a guess what the third part is? Just based on the pattern? Sine of gamma over C. Yeah, so we didn't prove the last part. We're just kind of inferring it from the pattern we had. But that is the full law of sines. So it's basically three proportions. Three fractions. And anytime we use the law of sines, okay, we only have to use two parts at a time. to create a proportion. Either the first two parts, the last two parts, or the first part and the last part. Which parts you use depends on what you want to know and what you're given. Okay. And as always, remember this fact you can still use. All your angles add up to 180. So what we'll do is practice solving one of each type. Okay, we'll do three different problems. For today, I probably won't get into word problems. I think we'll save that for next time. Yeah. Okay, so what's the first thing you should do here? Even though I said you don't have to worry about it too much for this test, but you will for the next test. Yep. Yep. Yeah, let's sketch it and see. Is it one of the three types, ASA, SAA, or SSA? Okay, so I've got, and it doesn't matter how you do it. If I put alpha here, put A across from it. If I put beta here, put B across from it. And if I put, let's put gamma here, put C across from it. Okay. What kind of triangle is this? Yeah, it's the side angle, which is side angle, angle. It's one of the three types that we should use law of sines on. Okay, so now we know. Let's use law of sines. Okay, another way you can figure out to use law of sines is to do something we've done before. Set up a table. Put your three sides in one column, put your three angles in the other. 20, 60, 4. And put a box on everything you need to find. By looking at the table, if you have a row with everything in it, that's another way to tell it's a law of sines problem. So I have a row here with everything in it, so that means it's law of sines. If you had side, 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 that would be a problem we can't do because you'd have a column with everything in it. If you have three sides, you don't have a row with everything in it. Okay, but this does have a row with everything in it, so that's another way to tell. So what could I find first here? Yeah, if I'm given 2, I can always get the third angle right away. What's the third angle? 100. Okay, so that's one thing we need. And now we can find B or C. It doesn't matter the order we do it in, so I don't know. Does anybody have a preference which one you want to do first? B. Okay, so we're going to find B. Okay, to find B, we're going to use 2 parts of the law of sines. We're definitely going to use this part. And the other part we use has to be the row in the table that has everything in it. The A and alpha. Okay, we have both of those. So I'm going to use the 2 parts I circled. I should know 3 out of the 4 letters there. Fill it in. Solve for the 1 letter you don't know. Okay, so set up your proportion. So sine of, what is alpha? 20. We're going to divide by 4. Equals, and now if we're solving for B, we're going to use row 2. What's going to go on top on the other side? 60 over B. And now when you have a proportion, how do you solve it? Cross multiply. So we got 4 sine 60 equals B sine 20. And my last step, to get b by itself. Yep, divide by sine 20. Do not use a calculator till the very last step. Okay, I don't want you to round off the sine of 20 right now. Okay, I want you to only round once in every problem. Okay, so that's gone, and there's our answer for b. Now we'll type that in. Okay, also, I think all of these problems are in degrees. So you can change the degrees for this section and just leave it there. So 4 sine 60 divided by sine 20. Okay, so we get about 10.128. Okay, 10.128. Now I have a row, well, I have 2 rows with everything in it. So technically I could use the first row or the second row to solve for C. But which row do you think I'm going to say is better to use? Yeah, the first row because everything is right. Okay, they gave it to us. So to find C, we're going to go back and use row 1 again. Sine 20 over 4 equals, what's going to go on the other side? Sine of 100 over C. Now, what did we just do on that right-hand side, especially with that 100? What do we have to be very careful about with the 100 we just used? Man? We found it. When you're doing right triangles, you can avoid using something you find to find other things. When you're doing these kind of triangles, you can't. A lot of times, you have to use something you find to find something else. So what that means is if we get gamma wrong here, you could still get b right, because we didn't use gamma to get b. But if you get gamma wrong, you're going to get c wrong. Okay? So just be very careful when you find something, if you have to use it. Okay, so we'll cross multiply. Okay, you don't have to show that middle step of the cross multiply if you don't want to. You can just say C equals 4 sine 100, and then divide by sine 20. If it's confusing to do that all in one step, you can show them the middle step, but that's what you're going to get. Any questions on that? And then type it all in exactly like you see it. Don't try to do 100 divided by 20 or anything like that. So 4 sine 100 divided by sine 20. Okay, 11.518. So that's C. Okay, with any triangle, what's something you can quickly look at that data? It won't confirm if you did it perfect, but it'll at least show you if you did something really wrong. What should be true if I look at the sides and the angles? Yep.
Angles add up to 180.
Okay, the angles should always add up to 180, so you can check that real quick. Looks good. What else?
The biggest angle to the biggest side, the smallest angle to the smallest side.
Yep. Biggest angle should always be with the biggest side, smallest angle with the smallest side. And also, what's the relationship between just the sides in a triangle? Like if I gave you any 3 numbers, how can you tell whether or not 3 numbers form a triangle?
If you add 2 of them, they should be greater than
Yes, anytime you add 2 sides together, like 10 and 14, 10 and 4 is 14, it's bigger than the third. 10 and 11, roughly, is 21. That's bigger than the third. So anytime you add 2 sides together, it should be bigger than the third. So those are just a couple quick things you can check really fast to make sure you didn't do something obviously wrong. Okay. So any question on side angle, angle? All right, so it's pretty, it's really pretty straightforward. Okay. This time, they gave you the diagram, so you don't have to make it yourself. Okay, what kind of triangle is this? And then once you tell me that, I want to know, should I try using law of sines? Trevor?
It's a wall, like a cube triangle. It's a cube triangle, but it's angle, side angle.
Yep, it's angle, side angle. So should I try law of sines? No. Okay, so let's set up our table. And see what happens. All right, so we don't know A. Do I know B? Nope. Do I know C? Yeah, what's C? How about alpha? Alpha has to be across from A. Do I know beta? 40. And I don't know gamma. So what was the trick I said you could use by looking at the table to see if it's a law of sines problem? If you have what? One row complete. Well, I don't have a row complete, but could I make a complete row very easily? Yes, I could. So find gamma by adding the other two angles up and subtracting from 180. So if we add those up, we get 85. So what is gamma? 95. Okay, why is it important that we get that one right this time? Yeah, what do you think we're going to use it to find? A and B. Okay, so this time we're going to use this angle because it's the only row that has everything in it to find A and B. So you get gamma wrong, this time it's all wrong. So just be very careful with your arithmetic. Don't make a mistake adding things up to 180. Okay. And just like the last problem, it doesn't matter from this point what you find next. You got to do gamma first. But then you could find A or you could find B. So Andrew, which one do you want to do next, A or B? A. Can someone give me my proportion to find A? Trevor?
Sine of 45 over A.
Sine 45 over A.
And then sine of 95 over 4.
Sine 95 over 4. And then when we solve it, get A by itself. Grayson, what will A equal after we get it by itself? You don't have to give me a decimal. I just want to know it's going to be what times what divided by what. And then we'll use the calculator to get the decimal.
I don't know, I have to figure it
All right, so what would you do first if you did it out?
out. Oh, it would be sine 95, A sine 95,
Yep, equals.
4 sine 45.
Yep, so you'd have A sine 95 equals 4 sine 45. So you're going to have 4 times sine 45. And then when you have A sine 95, how would you move the sine 95 to the other side? Yeah, just divide by sine 95. And that's your answer for A. Anybody have a calculator that they type that in and see what it comes out to? When you type it in, let's round to 3 decimal places. $2.839. Thank you. Anybody else get 2.839? Okay. All right. So now I've got A, I've got C. Could I use the Pythagorean theorem to get B? A couple people I saw said yes. Why shouldn't you? All right, because we found one of the sides. Generally, I would agree with that, but this time I do not. This is not a 90. This is not a right triangle. So if you use Pythagorean theorem, you're assuming you have a 90 and you don't. So if you had a 90, you could, but you don't. All right, so we need to find B. So Ayla, can you set up one side of my proportion to find B? So what rows are you going to use in that table? Out of these, we'll call them row 1, 2, and 3. Okay, you're going to definitely use row 3. And what else, if we're going to find B? Yeah. Which one? No, 1 would be if you wanted to find A. 2 and 3. So we got to use row 3 because it has everything in it. Row 2 is what we have to find. So now in your law of sines, just look up what part of law of sines has B and beta, what part has C and gamma, and then we just have to fill it in. What's the part of the law of sines that has the B and the beta? Do you have the law of sines written? No. Okay, let's make sure we have the law of sines written down. Okay, so sine of alpha over A equals sine beta over B equals sine gamma over C. So we're going to be using this part and this part. So we need to fill in all 4 of the letters that I just checked off right here. So what would be my left-hand fraction?
So, it would be sine 40 over
Yep, so start with sine 40 over B. And now somebody else tell me what's going to go on the right. Sine 95 over 4. Great. Any questions on setting that up? Okay, so now we're going to solve it. Get B by itself. Quinn, can you tell me what B will, you don't have to give me the decimal, but just tell me what times what divided by what.
It'll be 4 sine 40 degrees over sine 95 degrees.
Yep. Type that in, and that is your answer for B. Okay, does anybody have that? 2.581. Thank you. So I'm looking quickly. It looks like the smallest side is with the smallest angle, biggest side is with the biggest angle. If you add any 2 sides together, it looks like it's bigger than the third. So there's nothing obviously wrong. It looks good. Okay. Any questions on the angle side, angle type? All right, so let's take a look at the last type. Okay, the last type is side-side angle. And this one's can be a little tricky because of what can happen. It could end up being a problem just like the one we just did, where you just have one solution. It could end up being a quicker problem where there's no solution, which is nice because you're done right away. Or it could end up being a problem where there's 2 solutions. If there's 2 solutions, it's not harder, it's longer. You have to do everything twice. So we'll set it up and see if we can solve it. And I think most people will already know how to do the second solution case based on what we've learned this year. So let's just start it out and see what happens. So I put everything in a table. How can I tell that this is law of sines? I didn't even draw the diagram this time. I have a full row. And the way you can tell that it's the case you have to be careful with is you have a completely empty row. And you have no way to find anything in that row directly. In this problem, you are forced to find something first. What do you have to find first? You have to get beta first. Okay, and then once you get beta, if you get that, then you can add alpha and beta up, subtract from 180 to get gamma. Then if you can get gamma, you finally have a piece of information in the last row, which will let you get C. So that's kind of the order we're gonna go in. Deal with beta, then gamma, and then C. All right, so let's set up our law of sines to find beta. Francisco, can you tell me how I would set this up to find beta? Okay. You don't do, it's not sine of alpha over beta. No. What goes below alpha? Look back, do you have it written down? Back at the law. What letter is in the bottom of sine alpha? A, yeah. So in this case, A is 3. Okay, so there's the left-hand side. Can somebody else set up the right-hand side? Sine beta over 2. Before we even solve it, what's different about this proportion? Something different here than the last 2 problems. Yeah, we're missing beta. And what is beta? It's or an. It's an angle. Okay, we're solving for an angle. We've never had to do that. So we'll start out by cross multiplying. 2 sine 40 equals 3 sine beta. Rachel, what would I do next to start to get beta by itself?
You have to do it over so it's by itself.
Okay, so eventually we want everything that's next to beta on the other side. What would you move first? Okay, how would you do that? Yep, and divide by 3. Divide by 3. And now, just to save myself having to rewrite it twice, how would you get sine on the other side? Yep, the inverse sine. So, get the inverse sine of 2 sine 40 over 3. Don't try to cancel anything out. You just type it all in exactly the way you see it. All right, so let's type that in and see what happens. 2 sine 40. It's important you close the parenthesis because I got more stuff coming after it. And I get 25.374. So that is definitely an answer. If it was a no solution problem, I would have gotten an error right now. Okay, so this is not a no solution. But we don't know if it's a 1 solution or a 2 solution. Let's at least write down that answer. If there's a second one, I'll write it below it in the box. How would I check if there's a second answer? Yep. Yep, we use this diagram. And what kind of number is this? 2 sine 40 divided by 3. Positive or negative? It's a positive number. So you found one answer where sine is positive. Where else is sine positive? second. So what would I do with my answer to get the second one? Exactly, subtract it from 180. So, the second answer would be 154.626. Before I write that down, any thoughts about that? So algebraically, that is the other answer to the problem I wrote right here. But keep in mind we're kind of constrained because we're working in triangles now.
Is 154 the other angle you already know that they give you is 40 degrees stuff?
Yeah. This time, the other angle they gave me is 40, so if I add it to what I think the second answer is, I get 194.626. That doesn't leave too much for gamma. So, this time the second answer doesn't work. Sometimes you'll get the second answer, you'll add it to what was given, and it will work. Okay? It'll be under 180. But for this problem, there's only one answer for beta, which means there's only one answer for gamma, there's only one answer for C. If the second answer for beta worked, you would have two answers for beta, two answers for gamma, two answers for C. The information they gave you, that you don't have two answers for that. That was given. Just the stuff you're finding. Okay, so basically what I just said, I wrote all that down. You already know this from the ASTC diagram, but if you need to write it, that's what you do. So the second answer is 180 minus, well in this case it was beta, but you might be solving for alpha or gamma. Okay, so it's 180 minus your angle. But in our problem, if we did 180 minus the angle, we get that. And with the 40 degrees we were given to start, it's too big. It's greater than 180. So, any questions on how we found the second answer or why it doesn't work this time? Okay, so now from here we just finish it like a normal problem. But we do have to find something next. Out of the two things we don't know, which one do I have to do next? I have to do gamma. Okay, I cannot do C. So, how do we get gamma, Trevor? Yeah. So if I add those up, I get 65.374. And I'm just going to do it this way. Subtracting from 180. 114.626. Now that I have gamma, I can find C. All right, so now we'll just, I'll just squeeze it in right here. Let's find C. Tom, can you tell me how to set up my law of sines to find C?
All right, so sine 40 over 40.
Yep, we're going to go back to that piece of information we were given. Because at least we know that's right.
Is equal to sine of 114.626 over C.
Yes, sine 114.626 over C. Okay, so cross multiply. You're going to get 3 sine 114.626 divided by sine 40. Take that in, round it off, and that's your answer for C. Does anybody have what that will come out to?
Yeah, it's 4.243.
4.243. Okay, as always, check all the things that I keep mentioning, smallest side, smallest angle, all that stuff. Everything looks reasonable. So this is the only case that you have to worry about a second answer. If you have angle side angle, you never have to worry about the second answer because you don't use inverse trig. If you had side angle angle, you don't have to worry about the second answer because you don't use inverse trig. When we do the other two cases, side, 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 and side, angle, side, you're not going to have to worry about a second answer there. This is the only time you have to. Okay? Out of the 5 cases we will eventually learn, just this one. Okay. Any questions on side, side, angle? All right, so that's the law of sines. That's the 3 different types. All right, so you got about 20 minutes or so to start the homework. Also, if you need extra help, now would be a good time, depending on how I feel by 3 o'clock. I'm not sure how late I'll be staying for extra help. But you could ask me anything you want to know now about the test tomorrow. Except the answers, I'm not going to give you that. So on 435, I want you to try those problems, 5 through 8, 10, 16. And then I added 2 problems of my own. So this is an extra one. Alpha, beta, and C. And that's another one.